Hey everybody, Mr. Kelly here, and today we're going to be watching, well, we're not watching, we're learning about function notation, okay? So functions we talked about a little bit. They have inputs and outputs. One input can't have more than one output, but we kind of talked about them like with mappings and graphs and stuff. We didn't actually talk about like writing equations of functions and what you do with them. So this is going to be a little bit more like regular old algebra here. So we'll come back to that top part in a second. So remember functions, you put things in, usually we call our inputs x's, and you get something out. Usually we call our outputs y's, but another type of notation is to call those outputs f parenthesis x parenthesis. And the way to read that is f of x. Okay? Just another name for your output. It's another name for your y. Okay? So if you want to think about a function, f, which multiplies the input value by 2, you might think about this function f, and you might say, what does it do? Well, it takes the input and it multiplies it by 2. And then you get your output. The way that we write that in the fancy notation is basically the same way. Input times 2, that gives you output. Okay, but what do we call our inputs? We call them x's. So we say x times 2 equals our output. In other words, our output, how do you get an output? You do 2 times the input. And we just wrote a function. Okay? In general, functions always look like that. They look like f of x equals, and then they're stuck with x's. We did an example right here where we were saying where the input value is multiplied by 2, but you got equations where they do all sorts of stuff to x. So you could have a function where it takes the input and it subtracts 5. You could have a function where it takes the input and it squares it. You could have a function where it does 7 times the input and then subtracts 3. Those are all functions. So what you have over on the right side usually, in the red there, is kind of how I would think about it is what to do to the inputs. Okay, so on the right side is the rule for what you do to the inputs. This one says subtract 5. This one says square the input. This one says do 7 times the input minus 3. What you have on the left here is the output. Okay. Again, this looks similar to stuff you're more familiar with, like y equals 3x plus 5. In function notation, you just write f of x equals 3x plus 5. Okay? So we're just using this f of x as our output instead of our... we can fill out a table, we can do graphs with this. It's important that we can use these different representations. So if our function is f of x equals 2 times x, then we can plug in different inputs. And what you do to like kind of denote that or to show that is you write f of negative 3. What this says is I'm putting negative 3 as an input. And it wants me to find the output. So I'm going to take 2 and multiply it by my input. The rule is 2 times the input. Okay? What's the output I get out? Negative 6. You might see that written. We should really add another little column here. You might see that written as a complete statement like this. And the way to read this is f of negative 3 equals negative 6. And what it means is when you take the function f, whatever your rule is, whatever your equation is, and you plug in negative 3 for x, you get out negative 6 for y. Okay? Same thing here. We can put negative 2 in for x instead of negative 3. Oh, sorry. 2 times negative 2. You get out negative 4. In other words, f of negative 2 equals negative 4. When you input negative 2, you get out negative 4. Go ahead, pause the video, fill out the rest of these here. Sorry, guys. Fill out the rest of this table real quick. Okay, that's what I got for the rest of this table here. Okay. And of course, I can plot those points that I got from plugging into that function. Okay, so I can plot the point. You can look, here and say negative 3x, negative 6y. I can plot that point, negative 3, negative 6. Or you can look over here at this function notation and say, an x, an input of negative 3 gives out an output of negative 6. In other words, negative 3, negative 6 is a point. It'd be cool if you could kind of get in the habit of, watch this, not looking as much at this and being able to read this notation and plot points. That'd be kind of cool to be able to say, like, input negative 2, output negative 4. In other words, negative 2 for x, negative 4 for y. And we can plot these points. Okay. Here we go. Input of 2, output of 4, x of 2, y of 4. Okay. And it's just a line, nothing too crazy. We're just kind of talking about this different way of writing it with these f's instead of x's and y's. Okay. Cool. Put an arrow there too. Okay, now to like the main problem I need to be able to do. So the reason that we use this fancy function notation instead of just calling everything y, can't we just call them y equals x squared and y equals 2x minus 7? The answer is no, you can't do that. Because if you have both of these equations, like let's say you come to do a math problem and you have y equals x squared plus 5 and you have y equals 2x minus 7, and I say, hey, plug in 12 for x. Your question's going to be like, which equation you want me to plug in? Do you want to plug in the left one, both of them? I don't understand. And that's why function notation exists. It exists so that you can talk about function f, or you can talk about function g. So they give them letters, so you know what you're talking about. So let's jump over here. I want to kind of like look at what this means, and then I want to actually calculate it. So again, the way to read this is f of 3. Don't say f parentheses 3. F of 3. And what it means is input 3 for x and find the output. That's what it means. Input 3 for x and find the output. Now, you input 3 for x into which equation? Well, the f one. Okay. So it's saying take your f equation that says x squared plus 5. Don't write x squared plus 5. Input 3 in the place of x. So write 3 squared plus 5. What's 3 squared? 9. 9 plus 5 is 14. If you want to write one statement together, you could write this. Again, being able to read this would be cool. What this says is f of 3 equals 14. When you input 3 into the f equation, you get out 14. Okay. The other question I will ask you a lot is something like this. Okay, so take a second, look at that. It's kind of the reverse question. It's saying, hey, find the x such that the output is 15. In other words, find an input, remember a string's an x, find an input which gives an output of 15. Not saying plug in 15 for x. That would be if 15 was the input. It's saying 15 is the output. It's asking you, hey, what number would you stick in here? I bet you can look at this and figure it out. I don't know, you just try some stuff. And you plug in like 10. Now I give you out 13 if you plug in 10 for x. You gotta just guess it. Plug in 11 for x. 2 times 11 is 22. 22 minus 7, 15. No. 11 is the thing that you'd plug in for x if you wanted to get out 15. Now, we're usually not going to guess it. Instead, we're going to use algebra. Okay? So it's asking you to find the input such that the output is 15. Look at this statement. It's saying, hey, output equals 15. We're going to take our equation, and it says g of x, so we're going to grab this equation. We're going to write it down, and then watch this. We're not replacing the x with 15. We're replacing the output with 15. So instead of writing g of x, we're saying the output, we know the output is 15. Find the x, find the input. Okay. So I'm going to add 7 to both sides. I don't have to solve this equation. This is just good old-fashioned algebra. 22, 2x equals 22. What do I got to do? Divide both sides by 2. I got x equals 11. In other words, an input of 11 gives an output of 15. Oops, I used f instead of g. Come on, Mr. Cool. So you'll notice these two processes are very different. Sorry. And if you jump down here, I just want to kind of summarize. F of 3, like we did right here, we didn't do any algebra. We just stuck 3 in for x and figured out what the output was. So f of 3 comes down to, like, if you actually want to evaluate f of 3, it comes down to just like, I'm sorry guys, plugging in for x. You don't have to do anything tricky. It's nothing complicated. It's not hard. You just got to plug in for x. The hard one is the second question. Finding x such that f of x equals 3. Look at this right one. What did we have to do to find this x? Well, we kind of guessed it. But what did we end up having to do the real way? We ended up having to do what? Solve an equation. So like you actually have to do algebra. So finding an x, finding an input such that f of x equals 3, that type of problem comes down to solving an equation. Easy versus hard. One of them you're just sticking something in, the other one you're actually solving an equation. Okay? Let's do a few more of these together. So how do you do g of 5? Well, you just take your g equation, 2x minus 7. We don't write x. What is it asking us to input in the place of x? Huh. Figure out the output. 2 times 5 is 10. 10 minus 7 is 3. When you input 5 into g, you get out 3. That was easy peasy. That was this. That was evaluating f of a function, g. That was just evaluating it. That wasn't that. Now this is going to be a little tricky. Find the x such that f of x equals 9. Find the input that gives out 9. No. Well, now I got to take my equation, and I'm not plugging in x. Excuse me, I'm not plugging in 9 for x. I'm plugging in 9 for the output. I'm sticking 9 in place of the f of x. And I'm solving. Oops, sorry, I miswrote that. And I'm solving for the x. So I actually have to solve this equation. It's a real tricky equation to solve. We'll do it together. Subtract 5 from both sides. How do you get rid of a squared? Square root it. Okay, what's the square root of 4? 2. Don't forget the plus or minus. We'll go over that again when we study quadratics, but okay. Let's skip that. Let's do this one really quick. Find x such that g of x equals 43. Would you pause and give that a try? See if you can figure that one out. If you're stuck, you should be solving this equation. Okay. I got that an input of 25 gives an output of 43 for the g function. G of 25 equals 43. I solved that equation. Okay. So just make sure you're not mixing around these two things. Solving an equation versus just plugging something in for x. Okay. We'll leave this page to do some practice later. If you jump forward one more page, you get a little graph here. I want to make sure we're clear about what this means on a graph. Okay. So this seems like it's tricky. It's not going to be too bad, guys. Stick with me. You got a picture here of a graph. This is a graph of f of x. That's some equation. I don't know what it is, but I got a graph of it. When they're asking you f of -8, remember -8's our input, it's our x. They're just saying, hey, can you look at the graph and figure out an output that goes with an input of -8, can you find the y that goes with an x of -8? Oh yeah. When x is -8, what's y? Well, x is -8, y is 0. F of -8 is 0. If this seems like really different than what we were doing before, it's really not. Here, to figure out the output that went with the input, we plugged it into the function. We plugged it into the equation they gave us. If they give us a graph, we don't have to plug it into an equation. We just look at the graph. Okay, let's do this one. What's f of 2? What's the output that goes with 2 as an input? Well, let's just look at the graph. When I input 2, ooh, an open circle. Remember that an open circle means there is no y. It means there's not a point there. So what do you get when you plug it in 2? Nothing. We say it's undefined. A little tricky. Be careful with that. Let's try f of 4. When you plug in 4, what do you get out for y? When I go to x equals 4, well, it kind of seems like there's 2 y's. Oh wait, that one's an open circle, so I won't use it. So that's my y. -1. The point on the graph is 4, -1. Cool. Let's just do a couple more of these. We'll do 14 together, and then you guys can do 15 and 16 on your own. Find the x when the output, when the y equals 8. Again, it's saying, hey, find the x where the y is 8. Okay, well, let's see. Where is my y going to be? 8. Okay, it's right there. What's the x? 1. Okay. In other words, 1, 8 is a point on the graph. Find the x that gives an output of 8. That's value is 1. Okay? Go ahead and pause. Try 15 and 16 on your own. Okay? For 15, when you input -5, what do you get out? You get out y as 3. Okay? So make sure you're looking here. X is -5. What's the y? Use the filled in one. So your y is -3. Hope that one wasn't too bad. 16 is a little tricky. It's saying what x gives out an output, a y, an f of x, a y. Remember, f of x is just the same thing as y. Gives out a y, a 4. Okay, well, when's y 4? I like to draw a little line. Helps me. Oh, there's actually a lot of times y is 4. It's 4 right here. It's not hard to tell where that is. It's 4 right there, and it's 4 right there. So what are some x's that give out a y of 4? Well, -6 does, -1 does, and this one's really hard to tell. It's a little, looks like it's a little more than 2. Maybe I should say like 2.4. We don't really know exactly, and I don't want to worry about that. Okay, but there'd be multiple answers here, because if you look at a y value of 4, there's 3 different x's that have an output of 4. Cool. We can save these ones for practice in class. Don't worry. That concludes this video. Thanks for watching, guys.